It's been space the words.
No, it's sorry.
Gravitation,
A and B are the gravitational boys. M A and M B. So this is M A. This is M B. Subscripts, not F. These have no position vectors. Oh, with possession vectors RB and RA.
That's the unit
So,
vector.
oh. Hmm?
ER equals R dash over.
I'm not there yet.
Okay.
ER equals R over. I don't know why. There. It gives no explanation. All the textbooks don't have it. It doesn't even link to textbooks. This. It just gives a few questions.
Yes, it was at the bottom. Wait.
Nope.
Okay, maybe it doesn't. And the other ones it did.
I know. That's why I'm mentioning it. Okay. Well, they do give pages 163. You know.
wait, this is literally just the exact same as before, like
Yeah.
the taking away this vector,
Yeah, and unit vector. ER is unit vector from B to A. Yeah, R is between the two. Yeah, this is mainly central gravity stuff for gravitation. It doesn't give this, so now I'm questioning whether it's in the course.
Force exerted on A due to B is denoted by FAB. Why is stuff in the course is normally here?
Also, R equals. Yeah, you know, same thing we've done before with the RA minus R B. You know, we've done that, but
We get the gravitational constant. Do you remember?
No, we got it.
we gotta remember everything.
6.6.
Well, in physics we get a data sheet.
Isn't it 6.6?
But for this,
My
No.
calculator can store values, and isn't it 6.617 10 to the negative 11?
Yes,
Right
but
there.
are we given it?
No.
Of course not. Why would you be given anything?
I'm
apart from
pretty sure I'm not
people
allowed to use a
integrals?
calculator to store values then.
Let me just check the sheet.
So make sure you remember it's G
we'll
equals
check afterwards.
6.67 times 10 to the minus 11. Here are some nice units. Kilograms per meters. Seconds squared meters cubed. Those are the units. It's lovely, and I hate stuff. And the magnitude of the gravitational force equals F equals big old G M Ma and M E over R squared.
Multiplied by E bar.
Well, this is the start from, of course. It's denoted by FAB.
I don't know why it's written kilogram minus 1, but. Oh, wait, no, it's kilogram minus 1.
Yeah. The beginning one is FAB equals G and 1 over R, blah blah blah. A and B, I guess, there's E to the R, well no, subscript R, because, and then the magnitude is that. Lovely. Now I'm question.
FAB.
Oh, have you not?
F is like
I thought you
M,
removed the
M
A, it's
equals
just
M.
M reverse or
Yeah, we remove the negative and
just turn it into the standard formula in physics.
yes.
Nice.
And I don't think you ever used the one above, so
This is just a physics. Oh. I hope you've summarized this because I don't want you leaving out like 70 lines.
oh, I've summarized it a bit. It's probably not enough and a bit too much in parts.
Or
So-
we'll just read it.
How would you know?
Reading with me. In Newton's theory of gravitation, the gravity no.
Please.
So
Is this not just explaining why?
yeah, this
equals
is
to dm
inverse
over-
square law, and Newton's third law applies where FAB equals minus FBA. So
Yeah.
FAB equals F negative BA. Those are not E's, those are F's. Finding through, you have to find G, little g, through G, and vice versa. Hooray. So, we have the large one.
Nice.
Small m. So we're gonna use both this and f equals a. So that's in, we're finding a. So it's m a equals g and over r squared. These cancel, so it's a equals big M over r squared equals a equals g. Taking the center coordinates of the systems and we have the center of the problem. First, and Newton's second law.
Wait, what cancels out from the G and M?
Oh, okay.
Is it
So
just M1?
yeah, small m cancels.
okay.
Oh,
So
you
it's
should
only
probably
math
scroll
result.
down.
Hmm?
You should probably scroll down a bit. Yeah, that's better.
Nice. Okay. So
Okay, you've got an E.
yes, E is also here. I don't know why it's there because it's just gone.
E just appears.
E is there for
E is a
the
unit
minus what from I'm guessing the infinities thing.
E is just a unit vector from M to M.
Yeah.
Big M to small m. It just appears.
It appears and disappears and I haven't seen a point on it yet. So because of this, g r squared equals gn, which equals a constant.
See, okay.
Not the spheroid though. It is a constant though. Through the distance. As the inverse square law, as the gravity gets smaller, the radius gets larger. This is a constant. Proportionality and stuff. Yeah. Yeah, in projectile motion, g is always g, but it's not. And we only get nice approximations, especially when we probably what we have to use is 9.8 and not 9.81 because the variance in height.
So G and R are considered variables, product GR squared is always equal to GM.
Yeah. I didn't think I prepared
So
enough.
G1 R1 squared is equal to G2 R2 squared, right?
Hmm?
Is that what I'm saying?
Yeah, big G, big M.
No, G1 R1 squared is equal to G2
M of the large body. This mass is a satellite distance, and it's tiny. Probably.
Yeah, okay, so R2 goes to infinity, G goes to 0.
Yeah. Everyone okay with this?
Yeah.
I don't know actual questions, and there doesn't seem to be anything in the textbook, which is nice.
So I took the 1 person playing ever.
I don't dare try and drop things.
Okay, is that it?
Huh?
Is that it?
There's more.
Alright,
There's much more. We are a fifth. There's maybe a quarter.
Nice.
Yeah. I don't know. Next
Like,
period.
is it all just questions or is it just the...
There's more examples.
Yeah, so it's just lots of questions, yeah.
Like I said, there's angles and finding
Yeah.
something that I've bothered teaching because that's
Okay, so E just disappears at points and appears at points and we...
I don't know the point of E, it's just there sometimes.
Yeah, and sometimes it disappears. Like, in magnitude form, E just disappears.
Yeah.
Oh dear.
Satellite problems.
Ooh.
Can be assumed to have a circular orbit and a constant speed. With no elliptical orbits, those are too hard.
Oh, that's just saying there's no elliptical orbits.
Pretty sure. There's nothing of interest on that slide. Projecting is normally assumed to have a mass much smaller than the primary body, hence the being negligible probably. Also the satellite is
Yeah, circular and constant.
yes. Thankfully.
Example 1. Don't show us the work.
Oh well.
Also, have they just failed like National 5 Maths? 1.78, 2 significant figures.
Okay. We're finding
Okay,
out
it's into the 17. You haven't got them. You have 5 publications.
All I think all of these slides are from the Nat 5 page as well, which is funny.
Yeah, from the National 5 Maths.
The magnitude of the gravitational force between two solid spheres. So, one equals 200 grams, so I'm just going to convert that immediately to 0.2 kilograms. I don't know if everyone knows the thing. And M2 equals 0.3 kilograms.
This
This-
is the 2%.
With the distance is 150. So again, it's centimeters, so 1.5 meters. Again, let's just put everything into metric as fast as we can.
Centimeters are metric.
Proper units.
I did not see the thing. What was it?
It's fine. We don't need to use that anyway. So we have body 1, body 2, approximately the same.
Just do me a physics question then.
It is just F equals G M M.
Were you going to draw a diagram?
We can, but it is this
Yeah.
Can you get the question?
H and R.
Can you get the question?
The question. Nice.
Hold on, we've gone well past it. Wasn't on the phone. Yeah, I thought we were doing the first question. Yeah.
my fingers do not work. But yeah, it is just so numbers in. It is higher metaphysics this. So if this is in the exam, I'll be 6.67 times 10 to the minus 11. 1.5 squared and multiply that by the two masses, which is, so the F force is 1.78 times 10 to the minus 12 newtons.
You know, you could just.
Nah. I had space here too that I wasted. Yeah, so everyone understood.
Couldn't square it. That'd be why the answer's wrong. You couldn't square it.
178.
Yeah, but answer's
1.78. Danny just
Oh,
can't break decimal points.
what is a decimal point? Let's be real here.
Haha, funny girl.
Oh. Okay, last one. I hope.
Oh, this looks lovely.
Oh, that looks
Oh, it's
just
wonderful.
disgusting.
It's
Also, this is example 2, not example 3.
Welcome to engineering.
there we go. So I'm just gonna draw the diagram with big juke juke at 9n.
Don't ever do that again.
We gave you permission to call it Duke.
Would you rather be called Jupiter or something?
No. Just got a random name. Anything's better than that. Call it Samantha for all I care. Don't. It's not Duke.
What does 9n mean?
These are the masses, 9n and 4n.
What's n?
Mass.
Haha, we don't know.
It's just a mass.
It's just 4n.
Nine
To
mass.
be fair, it could be
9.
9 million and 4 million, and it doesn't matter.
Or 9
It's
mega.
still proportionally
Okay,
the same.
that's fair enough. Yeah.
Or megagrams.
Especially when you're not finding
Yeah,
it for a second.
mega is million.
You just gave up.
Yeah. And then here's our spacecraft, which I think. There we go, and all the window the stuff we need for us. Because he's gonna turn into a potato in Jupiter. So that's D. This is P, point P, and L is the radius, I believe.
Yeah.
If the distance between the centers of the planets is L, determine the distance D in terms of L, so that the space probe has a zero net gravitational force between these two.
Oh.
What's the term for when there's like a point between the
Lagrange points.
Lagrange points.
Yes, I'd spell it, but I can't.
What point?
Lagrange.
Those look
Lagrange.
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 It's a point
Lagrange.
where
I honestly cannot say what it's
Gravitational
It
force is
looks weird.
Yeah, it's probably American the way I'm saying it, to be fair. So, I should say, so net zero force is a Lagrange point where there are no net forces acting on it. So,
there is net zero.
the net zero force. Around here would be a Lagrange point. There are 4 points around every body. In front, some. In front, behind, and to the sides. I think most of them are, they're supposed to be stable, but they're not. It's not a two-way thing, it's all the other planets as well, which makes it unstable. So P is the origin. So There is a positive and a negative. Negative, positive. Because left to right, whatever not.
So up's positive, down's negative.
Left's negative, right's positive.
Okay.
Juke's negative.
That'd be illegal.
So,
Droop snoop.
Juke's the Juke would
The
snoop.
droop snoop.
Please stop now.
But why?
Snoop went droop. Snoop droop.
I wonder if Juke would snoop. Snoop could Juke. G, 9M, or R squared. Well, D squared, but sure, why not? We'll use D. Alright, finding D. Cool. So, why am I thinking that I'm going to be 0? It's not 0, obviously. And F2 would be G equals
GM9M.
We don't need M.
Yeah, little m is.
yeah,
No.
for some reason it's like this, and then L minus D to get this bit here.
Which way?
So, this is for Juke, we don't have the mass, it's just M, and same for here, we only have the mass of.
Wait, a power to
Saturn?
the power of 9.
Hmm?
L minus D to the power of 9.
No, that's 9M.
The bottom one. L minus D to the power of 9.
I think that'll be a 0.
Because obviously it's squared. So it turns out I was wrong and this one's negative.
Fantastic.
It would probably work either way, but
No, then. Just no. I don't know if
B1.
it works or not, but.
F1. What? F2. Underline these equals 0. So, what is it?
E1 F.
Yeah,
What about P2?
there is no P2. There's only 1 point.
E F1.
So,
F2.
so you just sub these in. Low M or R.
Yeah, they should just use capital M instead of writing different sizes.
Okay, I'll make that 20 M then. Is that better? Oh.
You make the McDonald's logo.
Oh yeah.
Oscar, copyright.
Oh god.
Wait, E's appeared?
Yeah, it's gonna get Greg. It's gonna disappear in the next line. So
Can we just pretend it's not real?
it isn't.
Well,
It's all in our hands.
just ignore it.
That's what I'm doing.
That seems like cheating.
What the hell?
So we're just subbing this in.
Wait, is that ER at the bottom of the top instructions?
Yeah, it exists. If you multiply
Wait,
it.
so the P is just telling us at point P.
Yes.
Okay, right. It makes it look like you put it in the equation, so it's P times M.
Oh no, it's the whole equation.
Also, so it just disappears now.
Wow.
Apparently so.
Okay.
Very odd.
Are we just supposed to accept that?
Yes, just accept this as real.
Should separate.
LSD.
L minus D. Okay, and that again equals 0. But now you see. Whoa.
I don't see.
Just slowly reading.
Yeah, I hope you can read it. I see you cannot. So then, we're gonna find something. Probably.
I mean, that's kind of what the question's asking.
If you don't just like run in and rearrange.
I mean, which is not really good.
Yes.
So this is how that is. We just rearrange it so it's like this. Because finding, multiplying it and stuff was more of a pain because. And then you just cancel the G's. Just cancel everything. You don't need any of it.
Oh, okay.
So
No.
9 over d squared.
Yeah, so let's. Yeah, so now you have 9 over d squared equals 4l minus d squared. Then you can rearrange it as 9l minus d 4d squared.
You mean put that squared on the alpha d
Hmm?
squared? Yeah.
Yes. And then you can.
Square root of bracket.
No.
No?
Apparently not. You then go L minus D minus 4D squared equals 0. I'll just need the square. You just solve for it. No. It is just solving for it. So. L squared minus D squared minus 2LD
Plus d squared.
9, just slap on a 9 on end, all of them, so that's 18. 9 equals 4D squared, multiply out those brackets.
What's that? 9l squared minus 9b squared.
It's plus 9d squared.
Oh, okay. And then minus 18lb.
Oh, that's positive 18.
Oh.
No. No way.
That is minus
It is.
No.
It is.
No.
Why not?
It's minus 9d squared. Take 18ld.
It's positive D, and the 9 is positive as well.
Yeah, okay. So L times L squared. Minus d times minus d plus d squared. Minus d add minus d, or minus ld add minus ld, minus 2ld. Yeah. Yeah.
Yeah, bottom. This is in the wrong order.
Sorry.
So that's
That should be positive. Okay. And then move over to D squared. So take just 5D squared minus 18D. This is a lovely order of doing this. That equals 0. then you put it into brackets, so find minus 3L D minus 0, and then so D equals 3L, and D equals 3L over 5. But here, D is smaller than L, so this one cannot be true. So we have yeah.
I cannot really follow what happened at the end.
Okay,
You
so
just shuffle it about and then you.
yeah, you multiply this out,
Good,
okay, and then you move this over,
good,
okay, then you have this, so you have 9L squared plus 5D minus 18DL.
Yep.
Okay, and then you just put that into brackets.
okay, that's literally it.
Yeah, and then you find D, but because of how D works, D is smaller than L, so it can't be D equals 3L. And there we go.
Oh, it doesn't.
Next one, guy.
Okay, so E disappears because there's an E on both sides, okay? Right? So E appears in both equations because it needs to be there.
Yeah.
Then when you move over, you can divide by E on both sides,
Yes.
and it disappears.
Mhm.
So it's not that it just randomly disappears.
Yeah.
And also, it's saying at P, comma, F1 plus F2 equals 0. No, P
What?
times F1.
What did you say?
You know how you said P times F1 equals F2, plus F2 equals 0?
Yeah.
Yeah, no, it's
It's
P,
comma.
It's comma.
Lovely.
Oh, okay. I
Yeah, that makes
P1
much
and
more
1.
sense.
At P,
At P, there is a gravitational force, net zero gravitational force. Yeah.
That makes a lot of sense.
That actually works.
So,
Done.
I think I get it.
Hmm?
I think we get it.
You think?
You're speaking for a team.
Well, do you not get it?
I do get it.
Everyone gets it?
As team leader,
Yeah.
I think we all get it.
Want to do another example? Or,
Uh,
because like, it's been like half an hour, so.
like and subscribe.